There we go. Alrighty, it's 6 o'clock, so I guess we can go ahead and get started. Welcome everyone to week 9 of the fall semester. We are officially over halfway through the semester. How is everyone feeling? Oh! No, it's definitely been brutal for a lot of us, but we're almost there. Thanksgiving break is within sight, so we have that to look forward to. First thing I wanted to talk about for this meeting before we get into the game, there are quite a lot of conferences and also internships opportunities that I want to talk to a lot of you about, because a lot of them would be great for you guys to apply for. Just real quick on Weather Challenge, don't forget to vote for this week's city or next week's city. Probably the Mid-Atlantic is going to have some good dynamic weather, so you might want to vote for that one. I won't talk too much about this city. The city is very difficult. Shout out to you guys who are keeping up with national consensus. I definitely am not. So good on you guys. But yeah, first thing I wanted to remind you guys about is the National Weather Association's 2021 Virtual Student and Early Career Professionals Conference. It's a long name, but yeah, they just released their agenda, so you guys can get a good idea of what you guys want to look at there. As a reminder, this conference is completely free, and additionally, it's on Sunday from 1 to 5, so it's not really a big time commitment. You know, you guys could easily attend all of those if you wanted to. What's really nice about this conference is that most of it is actually set up as panels. If you've never been to a conference before, basically they have panels, which is just a group of like 4 or 5 experts. They'll talk to you for 20 minutes about a couple of maybe questions, and then they'll open it up to the audience so you guys can ask questions related to whatever they're talking about. And so it begins at 1 o'clock with a keynote speaker, president of the NWA. I think he works in broadcast meteorology. And we have a panel for getting in the door, which is presumably, of course, getting in the door of a meteorology career.
And that one's actually pretty nice because they have the grad school route. There's somebody from Miller still there. They've also got the non-grad school route, which is National Weather Service and private sector, and they're all represented.
Awesome.
So that's a good group of people there.
Definitely, for sure. Then we have another keynote presentation at 2:30, and then another one after this. I don't know too much about Dr. Louis Uccellini, I believe that's how you pronounce that. But then after that, we have another panel for climate change communication, and then another one for the first few years in the business. This one will probably also be good for you guys, just trying to give you guys an idea of what you can expect for your career as you first start out. Additionally, they also have a post-conference meetup. I'm not sure what that's going to be like. But you know, potentially an opportunity for you guys to network. I think that'll be a good opportunity for you guys as well. Like I said, that's on Sunday. It is completely free, so I do recommend that all of you who are looking for meteorology careers definitely attend.
Yeah, and this is good for juniors and seniors. Freshmen won't get quite as much out of it. Sophomores will get a little bit out of it, but in 3 years, the job market will change.
Okay. Next, I got this in the Severe Weather Club inbox, and I definitely wanted to share it with you guys. They are now accepting applications for the William LaPenta internship program. I'd never heard of this up until today, but basically what this is you apply for this internship program, and they will give you, if you get in, they'll basically just pair you with a number of scientists in the NOAA office, and you guys will just participate in their research, in their research opportunities. A lot of the things that they will have you do and actually sound pretty cool. You have stuff related to forecasting. If you're interested in model development at all, they have that. This is something that I would be interested in, is forecasting tools that use GIS. They also have Python as well. A real good collage of things that you might want to be interested in. This is generally more research-based rather than operational, but like you would still get something out of it even if you did want to end up working for the National Weather Service or something.
And this is actually a 10-week summer program. It's called Research Experience for Undergraduates. So this is something that I did for physics back when I was an undergrad. So sophomores and juniors definitely apply. They pay for your housing, they pay for your food, you get a little bit of income. So it's a really good opportunity for the summer. It is competitive, right? So if you decide to apply for any of these things, send me your letters. I'm very happy to read them and sort of beat them up. I've been on selection committees for these awards, and so I kind of know what they're looking for.
That's definitely one of the things that all of these internship opportunities that I'm going to present you guys are like, is that they're very hyper competitive to actually get in. Once you do get in, it's very non-competitive transitioning forward past them.
And some of the AMS scholarships, like when I was on there were only 4 applicants. So apply. If you don't apply, you can't get the money.
Right, exactly.
Yeah.
Yeah, this particular internship, all you need is a personal statement, like a cover letter, a resume, transcript, and then 2 letters of recommendation, one of which has to be from a meteorology professor. So definitely all of you should probably apply if you're a junior or a sophomore. This is definitely a good opportunity for you guys.
If you're a senior who's not graduating in May, right? Super seniors, you get one of those.
I think they'll accept grad students too if you're going to be going into grad school.
Really?
I think I'd read that. So if you're doing grad school, you can apply as well. Another very similar opportunity is the Hollings Undergraduate Scholarship. Very much the same thing, very hyper-competitive scholarship. But what's very interesting is that if you do end up getting it, in addition to just general financial assistance for your schooling, they will also hook you up with another 10-week paid internship over the summer at a NOAA office or a National Weather Service office of your choosing. So like, again, definitely just a really good opportunity. This one is specifically for sophomore students. So if you are a sophomore, definitely consider applying for this one. It's all over the summer. Here are the requirements here. Very hyper competitive, pretty hard to apply, but once you do, it is a great opportunity. Definitely beefs up your resume. I will post this all on Discord after the meeting.
I think I posted it at some point.
Yeah, one of them. Yeah, I don't think the one you haven't heard of.
Yeah, I don't think that one is. So I'll definitely put that one on there as well. And then, of course, we've talked about this a couple times before, but they are also accepting pathways applications. Again, very similar to the other ones that we've described. This is a very hyper-competitive National Weather Service specifically internship program. I don't think it's actually just a summer thing either. I think they will have you employed throughout the year.
Yeah, it's during breaks, so Thanksgiving break, Christmas break, and over the summer you'll be working.
Right. And so they will work you either part-time or full-time. It is a job though. You do actually get paid. It's not just like an hourly thing either. This is a real job.
I mean, that's a good salary if you're still in school.
Oh yeah, this is fantastic. Here are the locations. We got one in Boulder, Michigan, Indiana, and Minnesota as well. They will
likely add more.
Probably.
This just came up. So they will likely add more locations.
Yeah, they'll probably.
More of them come out in the beginning of the year, mid-January, when a bunch of them get released.
Lincoln has been on the list before.
Yeah.
So that one's closest to us. I don't know if the Quad Cities has ever been on the list.
I haven't seen it. St. Louis was on the list last year.
Yes.
I applied for the St. Louis one. So with these, I applied for this last year. And so don't feel bad if you don't ever hear a word from them, because I heard nothing. After I applied, not we don't like you, or we like you, and need anything. And so
they probably have a couple hundred applicants.
yeah, I mean, it's really, really competitive. And so, I mean, I even worked with a weather service person from St. Louis for my cover letter and various other aspects, and I still didn't get any interviews or anything else. But yeah, so this is one of the ones that if you don't hear back, you just don't hear back.
Right.
Like the other one I applied, there'll be another one coming out for summer internships. I did hear back from that one. There were too many veterans, so I didn't qualify. I applied for it. But yeah, so like I said, don't feel bad if you don't get selected. It's just one of those things that a lot of people want.
If you don't apply, you don't get any of it.
Right.
So apply.
The other thing is that I know that a lot of these places are going to be like well beyond the scope of Macomb, but most of these internships, they do pay for your relocation as well as housing and food, and they give you a salary. So you don't have, yes, so you don't have to worry about finances at all. It's just a matter of getting yourself there. Here are the requirements for the pathways. The big one is that you have to have a decent GPA and that you're going to be enrolled in school while you're doing the program. But yeah, so I would definitely recommend anyone who has had even an inkling of interest in working at the National Weather Service or NOAA or something like that, apply for these internships. They're hell worth it if you end up receiving them.
Yeah, the Hollings and the pathways, those are direct lines to the Weather Service.
Yes.
They hire those people
They straight up say you'll be non-competitively placed in the National Weather Service if you complete those programs. So definitely recommend doing that. This last one that I wanted to recommend was something else that I had heard from I think I posted this on Discord, didn't you? Yeah, this is the NCAR Explore series. Basically, they just have a series of, I guess they're virtual lectures, I guess is what they are, where they talk to students about, various things. And this one that they're having coming up is very similar to the one that the NWA is putting on, which is the Student Opportunities at NCAR. Very much a research-based panel where they're going to talk to you about research opportunities.
This is specific to NCAR.
Okay.
So NCAR is the National Center for Atmospheric Research. Western Illinois University is a member of UCAR, University Corporation for Atmospheric Research. These are opportunities directly through them. So this is not AMS, this is not NWA, this is strictly NCAR.
So if you guys are interested at all in research opportunities, then I would definitely recommend doing this as well. When is this one going to be? I don't remember seeing a date. November 3rd. So yeah.
And it's 4 o'clock Mountain Standard Time.
Yeah, because they're based in Colorado, right?
An hour off.
Yeah.
It's
So yeah, that's just a rundown of a bunch of conferences and internships that I think you guys should definitely look at. Additionally, Anthony also posted a couple other conferences that he's considering going to as well. So I would definitely recommend looking at those.
Both, so there's one that was virtual, were the other two in person?
The Indiana case one is in person.
Yeah.
But I'm not.
They're not far away though, right?
No, it's in Danville, Indiana.
Yeah, it's not far away.
It's also Indiana.
Yeah, the other one, but it's a Thursday, Friday conference only. So.
I think when the Friday one only on Thursday.
Okay, so yeah, I'm gonna try to attend that with phone through.
And if you guys need letters for your professors, I'm happy to write something.
Oh wait, I don't have your class that day.
I know. I'm just putting it out there.
But yeah, that's all that I wanted to cover for you guys. Are there any other questions, comments, concerns? If not, then I think I can turn it over to Dr. Finch, where she's going to be hosting straight weather trivia.
So what we're going to talk about is spring weather. I teach a severe weather class when I can. I was supposed to go up here this coming spring, but I'm offering natural hazards instead. I'm hoping next year I'll be teaching severe and hazardous weather. One of the things that I do in my severe weather class is called strange weather of the week. And so every week we look at something that is just wet. And that's the weather. So for our strange weather of the week, I have a number of pictures, and I'm going to start out with some that are kind of easy. And the way this is going to work, what I'd like you guys to do is split roughly in half. And I would like for your groups to discuss how you think this is working. Why do you think it's happening? Okay, and if you think you have an answer, let me know. So go ahead and break up and get somewhat closer together so that you guys can actually chat.
Now we're all good. Being serious. Yeah, and you get through it.
All right.
No.
Rex, take a
All right. So what I'm going to do is I'm going to show you a picture or a video or something, right? And you guys talk and figure out what's going on. So the first couple I'm going to do are pretty commonly known, right? They're not that odd. All right, so we're going to start out with cap clouds. Here's an example of a cap cloud. So talk about this and let's figure out what's going on and why it's happening. Now, if you're sure you know the answer, go ahead and raise your hand. Discuss it with your group to make sure everybody in your group knows how it works. So here's a picture of a cap cloud. Here's another one. This one's hugging the mountain a little better. Here's Here's one. It's pretty much hiding the mountain. There's a mountain in there. No, there's a mountain in there. Oh, you bet, absolutely. Yes. So the question was, can cap clouds happen over cumulonimbus? Yes, I see it all the time around here. Really?
What is a cap cloud working on?
It looks just like this. You have a towering cumulonimbus and cap clouds right over the top of it. Yep. Yep. Definitely a Midwest thing. So do we know how it happens over here? They're discussing. Do we know how it happens? How does it happen? Why does it fall?
What do you mean we're in the Midwest like we're supposed to know? There's no hills out here. I saw you in elevation one day and it scared the hell out of us. But I do know that. Well, I don't know. I know it's serious.
Let me make sure I'm sharing the right thing. So here's our cap cloud. All right, yeah, I think it's just us. Okay. I don't even know which mountain that is. Do we know?
I think so.
How does it work?
So what we think is that it has to do with atmospheric stability. Basically,
Okay.
okay. So basically what we suspect is that normally in a very stable atmosphere, air is not low levels. But because there's a mountain there, of course it's going to be forced up the mountain.
Okay.
And so when it's going up the mountain, it's going to lose moisture because it's rising and all that.
Okay.
But of course, once it reaches the top of the mountain, it's not going to go up anymore because it's a very stable atmosphere. And so that's why once it reaches the top, it's not going to lose any more moisture. That's why there's no cloud. That's why it happens.
I like it. One thing that I will add, okay, and anybody who's taken the introduction to cloud air class, you lift the air up, its temperature decreases until it reaches the dew point, then poof, you get the cloud, right? In this case, on this particular picture, what I'm doing is I'm warming all of this, and it's all rising. Now, normally you're right, these cap clouds are right on the top. But in this particular case, it's literally daytime heating and rising air through an otherwise stable atmosphere that gives you that.
So it's similar to lake effect.
When you have lake effect snow, the air is coming over and literally picking up moisture from the lake. And then downstream is where you get all your snow. So yeah, on this one, I'm lifting up the air until temperature equals dew point, poof, I get a cloud. It's not going any higher because the atmosphere is stable. Does it make sense? Yeah. If we were to lift this up, I'd have clouds as high as I was going to lift it. But the only thing lifting this really is the heating coming from that mountain. Oh yeah, that's a cap cloud. You can have cap clouds over thunderstorms. Let's see. Here, right? This is what I often see, something like that. The cap cloud right on the top. But yeah, lots of examples of cap clouds, even over thunderstorms.
It looks like someone put a Milky Way contact.
Yes, exactly.
It just looks like someone just like dropped their big.
I mean, if you don't know anything about meteorology, you're like, holy crap, this can't be normal, it's aliens. So,
Right, on the cloud, how is it right above it? I mean, it already reached the dew point, and there's a cloud right above it.
what's happening is as the thunderstorm goes up, it carries with it a bit of that unsaturated air right on top of it. And that's the part that gives you that drape.
So in that picture right there,
This one?
Yeah, what is happening? Because it's right underneath the cloud.
So this one is not actually a cat flap. That is the triple pause. This is the overshooting pause. And you have to be careful when you do these little image searches, right? Because like, wrong. Right? All right, so that's cat flap. Let's see what's next. Is that gonna work? Yes? There.
Well, this happened over my house once.
So that's correct.
We're in a game, guys. We're in a
Right?
Talk about balloons.
What do we think?
So that's apparatus.
What that?
So that's
That's a kind of apparatus, yes?
Yeah, that's apparatus or gravity waves.
Yeah, I mean, it's gravity waves. Yeah. Apparatus tends to have like more wave life, they're smaller, and they're just apparatus. Yes. What's that? Apparatus. Those are basically, if you look up the class, it looks like all these pretty waves. Just a bunch of waves on the bottom of the class, that's apparatus. Right. In this case, it's this. This is actually what we call a ducted gravity wave. Ducted gravity wave. This is it, right?
Something probably related to what's happening.
Yeah? Yeah.
No.
So how does this work exactly?
See, this is why I'm gonna take water out of this.
It does. Gravity is the restoring force that pulls this back down.
So it's like different gravity in the air.
No,
Pressure?
no, it's just regular gravity. I
Yeah.
have something that sends it up, either the mountain downstream, gravity pulls it back down, and then it responds. Yeah, wild, right? Now, anytime we have something like a ducted gravity wave, we have an atmosphere down here. And then at the top of this wave, because notice it's pretty flat, right? I mean, this isn't really convective.
Also, there's some rain, like.
There
off
is.
the distance as well.
You bet, absolutely. At the top of this is what we call an inversion. A temperature of, where the an area of the atmosphere where the temperature cools with height. Now, if I think about it, warm air wants to what? Rise, cold air wants to sink. If I've got a region of the atmosphere where it is the opposite of what we normally think, warm air is on the bottom, cold air is on the top, it's not going to rise or sink. That is the duct. That is the top that keeps doing this. And the top of that inversion, we're literally doing this to it. Yeah, that's what you see in that cloud. Pretty cool, right? So this is a gravity wave. It's not like the gravity waves you hear about in like Einstein's theory of relativity, right? It's not the fabric of the universe gravity wave.
Isn't that no longer a theory anymore, but they actually.
Yes. Oh, exactly. Yep, we can detect it. But the reason it's called a gravity wave is because gravity is the restoring force. I push this up, gravity pulls it back down. And you continue this little wave. Pretty wild, right?
Or it's just magic.
Meteorology.
You don't have to be on.
All right, here's one. Yes?
There was some here last week.
Yeah, we do have them around. Yeah.
Okay, so the weather channel is where we popping out, but nobody posts this. And it happens.
I got many pictures.
So here's another.
I don't know.
There's one a little further away.
August.
Okay, atmosphere oxide of fluid, and that's all I got.
Okay, here's one.
Yeah, it looks like it's tiny, it's a tiny wave.
It is tiny waves, yes. Tiny breaking waves, no less. How does it form? For those of you guys who are advanced, don't say anything.
I actually saw these one time on a wind flow.
Yeah?
Really wild.
Nice. So this might give you a clue about how they form. Think about the top versus the bottom.
Is it inversion layer again?
It's not really an inversion layer. Yep.
It's the same thing that in the lenticular, whatever you call it.
Lenticulars, yes.
Except that there's also wind that's forcing it out at certain angles and this comes and it spills over and it's actually
Close. Very close. You're very close. In order to get Kelvin Helmholtz, what you've got is slower wind here, because the mountains in the way, and faster wind up here, which is pulling this up and causing it to roll over. Does that make sense? Very cool. It is. Yeah. I mean, there's no doubt something crazy is going on here. Yeah, and we do get these around here occasionally, not that often, but occasionally.
Wait, would it form because of, I guess, building or anything, or is it just?
I'm not sure a building would be big enough or high enough. Because if you think about the buildings, they're usually not where the condensation in the cloud occurs. But the top of the mountain is.
So how would it happen here then?
Here, what we have is, basically, there's a layer in the atmosphere, it could be a low-level jet, right, where the wind is going faster. And all I have to do is have condensation in here and then roll those hops. So that's how we get it around here. So that's actually an interesting research question. Do we get Kelvin Helmholtz around here when there's a low-level jet in the area? I bet we do.
Once every 5 years.
I know, we don't get them very often. Yeah, but that's what you need. You need slower winds at the bottom and faster winds at the top. Like roll those tops over. And it is exactly breaking ocean waves.
So mountains are really good in cities.
Yep.
So you're they're blowing higher, like the rocks, like you be blowing higher rocks.
Only if it's unstable. Remember that when you lift the air, you have to compare the temperature in the bubble of air to the temperature everywhere else. If the bubble is still colder than the environment, you're going to get something like this. If the bubble is warmer than the environment, you're going to get thunderstorms. So that's the difference. Whatever the atmosphere is that you are lifting the air into. Yeah.
So it's too cold to rise.
Yep. Too cold to rise. You got it. Question?
Oh, I said it was last week.
Oh, yeah. All right, let's see, what else?
That's a big wave.
Yeah.
Huge.
How about that?
Was this, is this similar to, what's that called?
Oh, punch cloud?
Yeah, whole punch, is that what, is this similar to that?
Similar, but what do you think would cause it to look like that?
Is the jet stream dipping down into it?
It's something more human derived.
Oh, is it a plane?
What's that?
A plane?
Yeah, that's exactly what causes particular
A
light.
plane, like, you're supposed to it?
Yeah, the plane went through the clouds, so these are probably alto or cirrocumulus, mid-higher atmosphere, right? An airplane, oh, come back. An airplane went through this. Now, what happens when an airplane goes through this, right? The first thing that happens is the airplane puts some stuff out the back. What is most of the stuff that comes out the back? Any idea?
Carbon monoxide.
It is not. Water vapor.
Oh.
It is water vapor. There's a little bit of black carbon, right? Because it's incomplete combustion in the engine, little bits of the engine are flying out. But mostly it's water vapor. What happens here is you've got your water vapor in a line, right? Because it's an airplane. This water vapor freezes because now I have something to freeze onto, the little bits of carbon, right, coming out the back of the plane. So I'm freezing onto that, and this is actually snow coming down.
Is that why it's darker?
That is why it's darker.
Okay.
Yes. The reason that I have snow coming down is because this cloud back here was either mixed phase, means there's water and ice, or water, right? It hadn't frozen yet because there's nothing up there to freeze on. As soon as I get some ice, the vapor pressure, the pressure around the ice is lower than the pressure around the water. Things go toward low pressure. And so this is literally stealing the water from the cloud around it. Right? Which is why the cloud around it disappears. It gets in and falls down the snow. We are literally stealing the moisture from the cloud that's already there.
So because the snow, I'm sure, like, melts apart.
Oh, way before, yeah.
Would that also, aren't burgers just rain and
It is.
down, so that's.
And Virga can be snow.
Okay.
Yep. This is Virga. Yeah. Pretty cool, right? Mother Nature, she's amazing. All right.
So this was for winter, right?
This particular one, probably
Trees were bare.
fall or spring, yeah.
Look at those trees, those are bare,
Yeah.
those are too bare for June.
Oh, come on. There we go. All right, what else do we have?
Oh, yeah.
Okay, we'll look at fire.
Yeah.
So here's a nice example, or not nice example if you're the guy,
Yeah.
right? Here's another one. That one's a bit more extreme.
That one just hates snow.
Whenever there's a good reason why people used to think that was magic, like, come on.
Oh, absolutely. They're called fire
If I
devils.
saw that today, I would think God is angry.
These are called fire devils or fire tornadoes, depending on your culture. Where do you think they happen most often?
Just
There's too many mountains out west.
Yeah, that's
Could be the desert southwest, but Australia.
Of course.
Yeah. The killer spiders, you know, the crazy animals, they were stuck together. Right. Yeah, most of these actually occur in Australia. We did have a couple in California over this past fire season. Yeah. And like when it happens, it is inferno. Anything in the path is pretty well gone. How do you think it forms?
Fire is emitting a bunch of gases that rise very, very fast. When you have even a light little breeze come, they get across and then start spinning.
Yep. Yeah. Fire itself is creating the heat and hotter it rises. Absolutely. All you need really, if I have a wind coming in, is something in the way. A building, a tree, anything.
Can it create like its own weather system?
Oh,
Like, is there
absolutely.
like the,
Yeah.
the like electric storm,
Yep.
created by like fires and stuff?
You guys have seen like smoke rings, right? Smoke rings. I think the smoke upstairs, they can make some up for your class one day. But basically, the ring, it's a ring, but it's rolling in on itself. Those things go out and they'll go halfway through the string before they dissipate. Once you set up a vortex, in the environment, it separates itself from the rest of the environment. This absolutely takes on a life of its own. Yeah, it's a stable configuration, that vortex. Question?
No, actually, something similar like this happens a lot. Well, not on fire, but something similar happens a lot at my old elementary school. It was built in a weird way where the walls were facing west, and they would go off the walls of the art department and then the kindergarten and then spin up.
Yep, spin up those,
And
yep.
so without any warning and reliably every single windy day,
Yeah.
we would have like a gust tornado in the middle of the playgrounds.
Beautiful, nice, love it.
how many like dust devils we had at my elementary school.
Absolutely.
It was surrounded by woods on like several sides, so if the wind came in just right, it would just.
Yep, swirl up. Yeah. Did you have a question, comment?
I was gonna say, if if there was snow, it's not even possible, because is this because of, is this usually in dry air?
Often it's in dry air, but if you think about an environment like this, there's so much heat, it's dry.
Okay, so
Yeah.
like, it would not be possible to have a normal year, like you post.
No,
Don't.
no.
I'm
No,
just saying,
you
I'm
wouldn't
not
have a
watching
supercell
short
and a
videos.
tornado anywhere close.
It's the Australians, they're
Yeah. Now they do have something called an NST, non-thunder or non-supercell tornadoes, NST. Basically, there are valleys in California where basically the middle of the valley is like a front, right? Air coming down, they look a bit different. If they're coming down at slightly different angles, they set up these tornadoes, and I've seen videos of like 10 in a row, tornadoes. Whew. Yeah. Yep.
Couldn't that also be a cold war tornado?
This one? No.
No, no, the non-supercell.
I mean, we don't generally think of tornadoes as cold core versus warm core. We do that for lows, just because we've got mid-latitude cyclones, which are always cold core. And then we've got hurricanes, which have the eye and sinking air, therefore warm core. But yeah, we don't often think about tornadoes as cold core versus warm core. They're too small to know what's in there, typically. Yeah. Other questions here?
When does that burn itself out?
Ooh, I know. Yeah, you'd have to shut down the wind, which, what are the odds when you're creating your own? I mean, warm air rises, therefore you're pulling in the wind. Oh yeah, until you shut down the fire or rain comes, these last a really long time. I want to see, let me see if I can find a video.
This is like that tornado or buffer.
Oh, come on. I'm not sure if this is going to be a good video or not. No. I'll have to find one.
You go back to the search engine
Mhm.
and just click on go up and click on video. And they have some.
Yeah, it's not giving me the kind of video that I want, though. All right, I'll look for it.
So I'm curious, 'cause,
Sure.
about these ones, because sometimes, I don't know if like dust devils get strong like this, but like, so in Florence, as you know, Arizona is just.
Oh, very flat, very dusty.
So,
Yeah.
there'll be some times when like, there's just, like, it's kind of, it's not as like insane as tornado, but there's like, there's something that comes through just takes stuff up.
Yep.
And it just, there's no clouds.
Yep.
There's nothing.
Yeah, those are clear air dust devils. They're also clear air water spouts. And yeah, they're strong enough to pick up light things. They're strong enough to throw some light lawn chairs and stuff like that around. Oh, yeah.
Oh, yeah, and like, we'll just like hit things.
Yep. Yep, and anything that it throws could do damage, so, yeah. Definitely. So here's one. That's the tornado.
Oh, Dr. Finch, it says that your screen sharing is paused.
Yeah. Yeah.
I think we're fine.
But your screen sharing is.
You know, I never really say this, but
All right.
I feel like around here we have boring weather.
You shut up.
Say boring weather. Yeah, well, like there's fire tornadoes and like.
You what?
No, you don't want Australia here. No, we don't want monsoons, we don't want torrential rain, we don't want tornadoes. Hear me out. Where I'm from, we get like one tornado every like 10 years, and that is it. You know what? Yeah.
So here's the one.
Oh, I see those all the time.
Yeah.
Wait, so that's simple explanation.
That's-
This was my brother's house, right? That is the frost line.
Oh.
This is the frost, everything else is not.
I can easily explain it to you, right?
Yeah.
Go
Go for it.
It's just because like the sun, the shadow keeps the air cool and the sun heats up here.
Yep.
You can see it in your house too. It's
Yeah.
really cool.
Yeah, so my brother was like, what the heck is going on? So he sent me this picture, like all freaked out.
I see it all the time.
Right, right.
I see it all the time at my boyfriend's house.
Yeah.
So we have so many trees, you can just see the outline of where the trees bend, that's sunrise.
Exactly. Yep, he'd never seen anything like that before. Here's one. Yep, you're looking at the ground and those are perfect little marbles. I think it's there. Yep,
Okay, so there was a storm that had freezing rain,
yes,
and eventually ice formed in some places, and that ice is colder than the surface around it. And so if any freezing rain got there, landed on that bubble, it would stay there and freeze, but if it landed on the ground, then it would just warm and, it will fly where you got it, right?
close, but let me give you what the people said who took that picture. They're like, it had so much freezing rain, it was crazy. And then the next day we got up and we saw this after a little skip of snow. There's definitely freezing rain under there. What the heck does it look like?
So it happens overnight, you said?
Acne.
Is it-
Yeah.
Someone finally lost all our marbles.
I know, exactly.
And that's where they went.
Any guesses?
Imagine like that.
Yeah, you did build a lot of them, huh?
Does it have to do with Bertrand's process, the same thing that kind of costs $1.5?
No, it's simpler than that.
Oh,
Isn't it just crystalline structure instead of,
I mean, it's water, right? Frozen water. What happened was there was a little wind with the ice storm. And so partway through the ice storm, this tree and put all these little bits of ice everywhere. And they grew like that. Yep. Pretty wild, right? They're perfect little spheres. And so basically what's happening for each one of these, you had like a little piece of ice here, however big it was when it came off the tree. Ice coated it and coated it and coated it. And that's what you ended up with.
approximately what is the scale of these marbles, like marble size or?
Yeah, marble size. Yeah, they're not that big. Yeah. Pretty wild, right?
I'm willing to urge to pick one of those off the ground,
I
just
know.
pop it in my mouth. Like, it looks like the best tasting ice cream.
But they're stuck. I think you'd have to chisel the sucker out.
Okay, that's fine.
I used a hailstone as a way to keep in my drink one time.
Nice.
It doesn't really taste like this. It doesn't really taste like this. No, someone you just figure out. You have to repeat it.
All right, here's one. This is a Newfoundland.
Oh, yeah, sorry guys, I got it back. I love how you can tell it's like,
structured right next to the ice. Because that ice is not stopping.
I just said that. Well, like it's gonna go right through it.
Yeah, I saw a video of like, it's too bright out to see how it goes, security camera. And then without any point, just comes in the windows and it's kind of slaps it on.
Where are you standing on that here?
So yeah, we're standing right next to it.
Try it.
It's not so much quality of video. Well, that's what it was thinking.
Yeah. What do you think is going on here?
It's because there's an actual probably like the curve starts moving into the actual because of the water the shore is moving ice breaks.
And that's one explanation, right? There's like ice on the lake and the wind is blowing it on shore. But there's another explanation that it doesn't require wind at all.
It just means tide.
What's that? Not so much the tide. What you could have is if I've got a lake that's mostly frozen over, and this actually happens in some of the smaller Great Lakes, but the middle of it's not frozen over. Think about ice. It is less dense than water. So the ice expands, pushing the other ice out of the way. So that's the other explanation. Yeah, I'm not sure if it's windy here or not. You can't really tell. But we don't necessarily need it. And this is not a big lake, right? And so the lake isn't completely frozen over. As the ice forms and expands, it pushes everything else out of the way. But yeah, that's pretty dramatic, right?
How is that little house structure still standing?
I don't know.
It won't be for that.
Right, it won't be for long.
Oh, yeah, it's the door. I'm watching it till the house breaks. You know that. I mean, I do this all the time.
So let's fast forward.
Oh, yeah.
Yep.
Am I wrong?
I have no control over their language.
Alright, well, I'm pretty confident that I get out.
Has anybody been along the Mississippi River during the winter and the ice is flowing?
Yes.
It piles up. It does, you get the swirls. But if you're near the shore and the water is carrying all these big giant ice floats down, it piles up and up and up, and you can see something similar to this, only thicker. Yeah. If you go to Burlington, right, there's this walking park along the edge of the water underneath the Burlington Bridge. And you could go down to the marina. Often you see some ice piles like this down at the marina. Just because the ice gets put into this little inlet. Yeah.
You can also see it along, I always see it along the bridge between Muscatine, Iowa and Illinois. You can see it up along like the banks, because there's like, I think there's a pylon right next to the bank. So you can like see it just like
Yep, absolutely.
lining up.
Absolutely. Don't walk on it.
No.
Because you don't know if it's solid or not. Don't get out on it. Those things are turning each other over. I mean, it looks like it should be stable enough to walk on here, though. Right? All right, let's see, what else do I have?
The first time I went ice fishing with my dad, he drove the car right onto the ice. I'm like, what the hell are you doing? This thing can't hold the car. I was totally unaware. Like, yes, sometimes ice can hold the car.
Everybody seen those?
Yes, those are always so cool.
We get them in the Midwest here.
Doesn't it like also kind of happen in Death Valley where they have like a salt chunk?
It did, but that's a slightly different process because there it's really warm.
Yeah.
Right? Here, it's really cold. What's happening? How do we get this? They're called snow donuts or snow rolls. What's that?
Oh, I was talking to them, but I was like, isn't it like the same process as like, like rolling a ball for a snowman, but it's just like a little chunk of something like falls and it just kind of.
How does it keep rolling?
Gravity.
This gravity, yes.
Is a hill.
In the plains,
Wind.
wind. That's all you need. You need a strong wind, which if anybody's been through a winter here, yeah, we definitely have strong winds. So yeah, if you've got like a flat area that used to be cropland, walk outside town a mile and you got it. These happen all the time. In fact, the leading place in the world where these happen is in West. Yeah.
Winters suck, they look so cool.
They're really beautiful.
Wait for this one.
How about that? We've seen that
We've
recently.
all seen a million of those.
Yep. What is it?
Aliens.
So,
Aliens.
right?
The amount of people in my area use these wall clouds.
Oh, exactly.
Concerning.
Yeah. But if you see this for the first time and you're from somewhere like Africa, they don't have these, right? A lot of our foreign students who come here as grad students, freaks them out. We go ahead, fine, we're good. Okay. So it literally freaks them out. They don't know what it is. Or they don't know what thunderstorms are either. So that freaks them out even more. How does it form? So it's cool, right? But it's not that unusual. How does it form?
Is that rain in between those two?
It's probably right that
Over
layer.
there, like up in the middle.
Not really.
Looks more
So-
like rails now.
Here, there,
Oh,
right. So I wouldn't think there's really any hail or anything here.
So you kind of walk out of the building.
Maybe, or stud.
Yeah.
How does it form?
So there's a mass of warm air in front and cold air in back that's propelled by both the cold front and also rain that's cooling the surface.
Good.
So it brings all this cold air up and then it's pushing the warm air forward and this warm air sort of topples
Right.
over the cold air.
Yep, the cold air is back here, the warm air tops giving that shape
My
exactly.
favorite goddamn cloud.
You can also have what's called a roll cloud out ahead of your cold cloud. The roll cloud is out here, and literally I've got this and this causing that roll.
I've seen so many videos of people like on the beach and they're like, oh my god, what is that? Oh, wow.
Right?
Actually, I'm gonna spoil something. I saw this also in here, but there's a form of roll cloud called the morning glory.
I have that.
Happens over a certain gulf in
I have
Australia,
that.
I think.
Yep.
Yeah, and it's pretty much the same. Yeah, I saw the same.
Yeah.
Oh, that's so cool.
Isn't that amazing? In fact, people who do hang gliding, they flock here every year to go through the morning glory class.
Why is it called morning glory?
Because it's only in the morning.
Okay. It's the morning, but like morning, why?
It's cool. It's
Yeah, that's
glorious.
just, they named them that, local name, right? So there are other examples here.
Oh, that one was on Michigan, wasn't it?
Was it?
Here.
These two happen over Lake Michigan.
It's slightly different though. Not a whole lot different. So what's happening for these clouds and why they happen so often in this place in Australia is because of the sea breeze. Okay? Think about the sea breeze during the day. Here's the land and it heats up in the sun, the air rises. Pulls the air in off the ocean, which is moisture rich, rises, poof, you get a cloud. In fact, in Florida at 3 o'clock every day it rains. No kidding.
Wow.
What's happening here is you've actually got multiple sea breezes working together. And that's how you get these. Those are individual pulses of the air coming together. And the reason that it's only in the morning is because by the time the sun comes up, they dissipate. They evaporate.
So. It's farther into land though, and it like.
It doesn't get that far from the ocean, but I've got ocean here and ocean over here.
Further deep, if it changes the date, right?
What's that?
There are like deep clouds and it's basically.
Well, I mean, once the sun comes up and starts heating, they're going to dissipate. They're driven by the wind, but yeah, you're right, there's not that much moisture in them. Right. Well, if you think about the cold air coming from Canada, right? It comes down in pulses. It's a similar process. The cold air over the ocean comes in pulses. And that's how you think that's. Yep.
Well, on the topic of Australia, and how the hellscape is, did you ever hear of the storms over TV Islands? There's a storm that happens from like 6 months solid, every single day.
Wow.
3 o'clock, it will happen at the same exact place.
Nice. Sounds like a sea breeze thing.
It is.
Yeah.
It's like the way that the mountain is shaped.
Nice. Nice. All right, I think that's about all I have. So, yeah.
Wait, show me those ice flowers.
Oh yeah, the ice flowers are beautiful. Wow. So we're used to seeing something like that, right? This is frost in the flower. We're not used to seeing something like that.
Whoa.
This is also frost, right? What's happening is the moisture in this has a lot of bacteria in it, has a lot of salt, a lot of organic material, and it's expanding out of this reed. In addition to the fact that the moisture in the air is coming and landing to give a delicate structure.
Is that hoarfrost?
Nope, this is called a frost flower, an ice flower. So here's another one.
Whoa.
They usually come from things.
It's kind of like if you put like really malleable clay in a sponge. And shake it out.
It is, yes,
To
absolutely.
me, it looks like when you like put basically when you dissolve toilet paper in water, and it just kind of like.
Yeah.
I see that, or it looks like a loofah.
Yeah,
it does.
So scientists have actually tested these frost flowers, and they say that it is incredible the amount of live microorganisms that are in there.
Oh, jeez.
Which is pretty cool. I don't usually think
Oh,
of,
snap.
in other words, don't eat it, right? All right, that's all I got for you guys. Hopefully you had fun. Yes, good. I certainly had fun putting these together.
Oh,
Yes.
earlier today,
I can't hear you. Too much stuff moving.
I know like in the beginning of class, you wanted us to describe like the atmospheric concentrator and breaking out and stuff. I saw that too.
Yes.
It was funny. I mean, it probably was just the illusion of like, I